Good morning, everyone. I'm going to go ahead and get started. Good morning. Thanks for being here with me. So this is IAM303, and we're going to be talking about auditing and enforcing IAM best practices. My name is Tara Schofield. I work on the customer education and training team at Datadog. Do we have anybody listening, anybody in the audience who is a current Datadog customer? Okay, awesome. Oh, great to see. Thank you for being here. Hopefully we'll be able to show you a couple things that are new today, some stuff hot off the presses. So throughout our time together this morning, I'm going to ask you all to indulge me in a little bit of a metaphor. We're going to be speaking metaphorically. So we're going to be thinking about ourselves as construction workers on a road, right? And this metaphor works well for something like DevSecOps because often in DevSecOps, our teams are trying to move as quickly as they can, moving at the speed of light, developing more features, operating business quickly. And a lot of times us, especially security people or DevOps people, are tasked with securing the road as we're building it, right? Maybe it's not even paved yet. Maybe the developers are going fast, they're ahead of us, and it's our job to keep it safe. So that's the deal with the traffic safety metaphor you might have noticed at the beginning of the presentation. And oftentimes, the challenge, right, is how do we help developers build the road? How do we help the developers build safely without putting up speed limits, without being blockers to development? So that's one thing we'll be talking about. And for anybody who spends as much time as I do looking at AWS infrastructure diagrams, this is like some IAM humor for you because I'm going to talk a little bit about my role at Datadog right now. So I work, like I said, on our customer education and training team, and I develop hands-on labs to teach people how to use our suite of cloud security products. So I spend almost all day doing infrastructure as code, building AWS sandboxes, and then doing threat emulation for cloud attacks. It's a very fun job, and I spend a lot of time thinking about identity, both in how to emulate things like privilege escalation, but also when I'm responsible for building my own IAM resources that prevent our security savvy customers from hacking my lab environment. So I'm dealing with IAM drama all day long. I'm very passionate about it. And throughout the presentation, we're going to talk about a few different things. We're going to talk about what are some of the challenges, right, with, of course, DevSecOps, but just in general, how come it's still so hard to get IAM right? What are some of the challenges preventing us from implementing IAM best practices? We're going to speak about some general recommendations and guidelines for upping your game with IAM a little bit. And then I'm going to give some specific guidances for anyone out there who is looking to implement programmatic IAM best practices. And throughout that, we'll also be talking about things like DevSecOps tooling and especially tools focused on identity risk. So I imagine probably here at Inforce, we've got a few folks in the room who are cloud security people. I probably don't need to tell you this, but if you're not familiar with AWS IAM, it is by far the most fundamental skill you need to know about the AWS cloud. And every interaction between humans and services, workloads and different environments are going to be governed by identity. And we really believe that IAM is going to dictate the impact of an incident in your environment. And the good thing about this, what this means is if we get really good at IAM, if we scope our identities well and we design them for resilience, if we build good systems, we can really limit and mitigate the impact of security incidents that involve AWS credentials. And even this year, even in 2024, is probably no surprise, leaked credentials remain one of the top root causes of data breaches in the cloud. And whether that's they're leaked accidentally, they're stolen via vulnerability, or I know not that anyone would ever do this, no one would ever have this happen, but maybe they're leaked through some less than desirable application security practices. Leaked credentials, it's a maximum impact issue. And you might be kind of asking yourself why that is. And like I said, why is it still so hard to get this right, even though a lot of us have been working with IAM for a long time and know what we're doing when it comes to writing IAM policies? Why is it still so hard? Why do we still have these problems? And so I'm going to start by identifying a few reasons why we think that is based on our Datadog security research. And the first one is complexity. As cloud adoption has grown, our cloud environments have gotten so much more complex. And to really illustrate that, I'm going to compare it with a little trip down memory lane. So many of us that have worked with AWS a while probably began our journey working in a single AWS account, right? And we had a nice little boundary where we ran our workloads and we paid one bill for one account, and life was good and life was simple. And we would point and click, right? Click ops when we needed to get something spinning. Maybe we were spinning up tens of servers. Maybe there weren't quite so many services yet that we had to identify IAM actions for. It was good times. And then came infrastructure as code. And with that, the notion that maybe ClickOps wasn't actually the way to do it. Maybe it didn't really scale well. Maybe it didn't produce the deterministic results that we wanted. It wasn't reliable. And most importantly, it didn't scale well as more and more of our team started working in the cloud. It didn't scale as a strategy for engineering teams that were growing quickly. And so we tried to fix this by adding more. We added source control, manual reviews, code repositories, and tried to implement different CI/CD strategies to stop mistakes from making it into production. And so that's pretty good. That was an improvement. But it didn't really scale well enough either. We were still having problems. And so we added automation, right? Automation is the answer to everything. And we began to add automation to our CI/CD processes, automation that used complex math, maybe something like a semantic parser, more and more tooling to decide whether or not changes to our cloud environment were dangerous. And that's just cloud environment in general. You were really probably operating at a pretty high level if you had tooling in place specifically to make sure your IAM changes weren't dangerous. And again, automation, I'm not trying to dog on it. It was a great addition to the process, and it remains a good thing to have in place. It empowered us to move faster. But the flip side is, as we added more and more automation, more tests, more surface area, you guys might see a twist coming here, automation becomes the problem, right? Because engineers began to context switch between a lot of different tooling, all reporting in different ways. Teams were buried in seas of alerts without standard ideas of how to prioritize those alerts or how to action on them. And also just frustration, bad vibes, and an extension of our attack surface via our automation systems. To speak a little bit more on the issue of alerting, the result of all of this is something called alert fatigue. I'm sure you all are fairly familiar with what I'm talking about here. It's a struggle most people are dealing with today, most businesses. Alert fatigue combined with tool sprawl is truly causing teams to miss actioning on the most critical alerts while they waste precious time deciding whether many findings are true positives that are urgent, need urgent action, or false positives that could be ignored. And in fact, according to a study by Critical Smart, on average, an alert is triaged for 30 minutes, regardless of fidelity, regardless of the signal priority. And surprisingly, in larger companies with more than 1,000 employees, 27% of alerts aren't even being investigated at all. And we think that's really due to low confidence in the tooling and obviously frustration with all the noise. So speaking of tool frustration, tool and category sprawl is real. There is a lot of acronyms out there. There's probably been like 3 new acronyms invented this morning that I didn't even have time to put on the slide. So your engineers, your teams, you're dealing with your SIM, you're dealing with your KIM, you're dealing with your RASP, your WAF, etc. The list goes on of dedicated platforms that each promise to save the day when it comes to actioning on security and actioning on security alerts. While the right implementation and the right tool, it might do just that, it might save the day for you, we think it's really important to boil your tooling down to intent and try to design for resilience in the way that you're developing, releasing, and verifying your most critical system in the cloud, the most important thing, foundational to everything, the thing that's going to determine the extent of your attack or abuse, and that's IAM. So again, really looking at your tooling set and thinking about what tool do I have in place to protect my IAM system? So, as fun as it is to lay out problems, probably the reason why you're here is because you're a little bit more interested in some ideas on how we can improve. And our slide designer here added this nice intentionally black slide because this is like the dramatic equivalent of a PowerPoint drum roll, because we're really excited to start telling you some of our ideas about how to fix these problems rather than just listing them for you. Oftentimes, one thing that we really see for teams, an area where they're falling short in implementing DevSecOps practices, especially in shift left mania, all the shift left chat all about us, is that we think teams really tend to leave out measurements for tooling around the topic of developer friction. So developer friction is that idea that each time we introduce a new tool into our set of tools, we slow development down. And if a new tool is in place and our developers are releasing code more slowly, that means we've created developer friction. That's one thing we're really going to hit on today, is how do you put best practice audits in place without increasing developer friction. And every DevSecOps control should provide the right level of guidance to be actionable for your developers without slowing them down. That's one big theme. The second big theme is we need to monitor our DevSecOps systems, right? Because each DevSecOps tool that we put in place extends our attack surface. Many DevSecOps tools that we put in place require the configuration of new IAM resources, and many of those IAM resources have some pretty permissive policies in place to have them do what they need to do. So we're going to talk about that. And then lastly, we're going to kind of talk about this idea of back to basics. As we try to fight against tool sprawl, there's three things, right, that have been the basics through all of this that have helped us grow and scale these cloud systems in the first place, and that's logs, metrics, and traces. So we're going to talk about how we believe logs, traces, and metrics can help you as you fight against overly permissive IAM resources. We like to say at Datadog, my great colleague Rory McCune, you can't secure what you can't observe. So ultimately, your ability to alert and act efficiently is heavily impacted by being data-informed, in the way you evaluate and respond to any alert in your environment. So that could be an attack alert, a threat alert, a vulnerability alert. You're going to need as much data as you can get your hands on, and context matters a lot. So that's another thing that you'll see as I kind of talk a little bit more specifically about IAM tooling in a few moments. And even just like looking at this slide stresses me out a little bit, because it's a little bit like road construction. Back to our construction metaphor, we have access to all this different tooling, and we've got it plotted here on the spectrum of cloud native, native to AWS versus vendor or open source, pre-production to production. Some of these tools are focused on identity and access. Some of them are focused on other things. The biggest challenge as you try to improve your IAM auditing practices is going to be finding the right tool to do the right job, and then also trying to bust these myths that we see in some of our security research at Datadog, some of these kind of blocking beliefs that make it difficult to get your whole team on board with implementing IAM best practices. So you see three myths up here. Perhaps the biggest one, they're all quite important, but one must understand the language in order to be a good IAM engineer, and that's really a big theme, because what we see is that developers who are tasked with developing new cloud systems, new cloud applications, maybe find it frustrating. I don't know if anyone in the room's ever been frustrated when trying to write an IAM policy. I know I've been humbled by it quite a few times, and the problem with that is that when we have this blocking belief that we have to really know IAM to be good at IAM, to be able to scope down our roles, what happens is that people don't even try, right? It's kind of, I can't figure this out, I need to ship some code, and that's how we end up with maybe wildcards in our IAM policies, maybe overly permissive managed policies that weren't really needed. And that's one other thing you should be thinking about as you're thinking about your tooling is how do we put a tool in place that's going to help overcome some of these myths and some of these problematic beliefs on our team. Now, before we move even further into kind of the specific guidance portion of the presentation, I am going to get us on the same page quickly with just some common terminology. So don't worry, this is not going to become like an IAM training session. I'm sure many of you know IAM quite well, but we are just going to get some common language here before we move forward. So, and also just try to make sure we understand, we all have the same understanding of the facilities that we do and don't have at our disposal as we try to manage identities in the cloud. So it all starts with the PARC model, and the PARC model is principles, actions, resources, and conditions. Most people get pretty good at the PAR part, right? So principles, actions, resources. We find people get pretty good at this. They get up to speed on this quickly. It makes sense. Now, what we see is that conditions is where the tools are underutilized, where the logic is underutilized, and condition keys can really be the differentiator. If you're having leaked credentials, your credentials are being abused, condition keys can take a bad day to maybe not so bad day, and people aren't usually using them to the full extent of their powers. And then service control policies. So if you're not familiar with the service control policy, these are associated with AWS organizations. They're not on an organization by default, but you can enable them. And when you enable a service control policy, you can restrict access to services, API calls. You can basically just say, here's a list of things I never want to be able to happen in my environment. And that's a highly abstracted description, but if you're using AWS organizations, SCPs are a powerful tool at your disposal. And then lastly, this term least privilege. So I'm sure many of you have heard it before. So the goal of all of this, the outcome that we're really aiming for is true least privilege. And when your credentials are stolen, think about a role that has been scoped to true least privilege versus a role that has more permissions than it needs and uses, and you can really visualize why that makes a big difference. So going back to condition, one of the big implementations of condition keys that you're going to see an example of in a couple of minutes is designed with this idea of if our credentials are stolen, if we assume we're not going to be perfect, our credentials are going to be caught in a leak somewhere, they're going to be exploited, how can we at least make sure they can't be leveraged outside of their intended environment? Condition keys are a big tool that can help you do that. So we talked a little bit about why I think this is so hard, why people are still struggling with IAM. We talked a little bit about general philosophy, some of the things we're going to try to use as like our guiding principles as we talk more specifically about implementation. And we talked about common terminology. Now I'm going to get a little bit more specific with security tooling centered on IAM. So some of you might be AWS IAM Access Analyzer users, and this is a great service. It's native to AWS, and it identifies unused access across your organization and your accounts. And what's really powerful about it is it's based on actual usage up to 180 days in the past. So it can tell you my permissions policies that are attached to my roles and my users, how good of a job did I do? How much is that user really using the actions that I granted them access to in this policy? And then we're also going to talk about KIMs. So KIM is one of those new security acronyms, hot off the presses in some worlds. People aren't as familiar with this or something like that. And a KIM stands for Cloud Infrastructure Entitlement Management, and it's a tool that is in place to help you do this, to help you manage identity and access in the cloud. At Datadog, we have a Datadog KIM tool that's part of our cloud security management platform, and we also sometimes refer to it as Datadog identity risks. So you might hear me use those terms interchangeably. What Datadog's KIM does is it helps organizations achieve least privilege by detecting a permissions gap, administrative privileges, external account access. How easily could your permissions be leveraged by a different AWS account than the account that owns your IAM resource? It detects large blast radii, and then it also can suggest downsized policies for you based on actual usage. So I'm going to play a quick demo in a moment, and we might be able to look at the tool live as well. But you can see here, this is an example of an identity risk finding in Datadog that's leveraging IAM Access Analyzer data. It's looking at the activity, the usage of those permissions, and we define a permission gap in this rule. I believe this would be an example of a rule where we've created a finding for you because this user is using less than 40% of the actions that are assigned to them. So that's a pretty big gap, right? If they have a list of IAM actions they have permission to use and they're only using 40% of them, we have a big opportunity to move towards more least privileged access. And one other note here, no configuration is needed. So our KIM tool can leverage your IAM Access Analyzer findings without additional configuration. And if you don't use AWS IAM Access Analyzer, the way that this works is that the KIM tool would make use of your CloudTrail audit logs to be able to generate these findings. And with that, I'm going to play a quick video. So this is one of the product managers that owns this tool. It's going to tell you in a little bit more detail how it works, and you'll see it in action, and then we will go from there.
Datadog KIM helps you detect and remediate lingering administrative privileges, cross-account access, privilege escalations, large blast radius, and over-permissive entities across your clouds. AWS IAM Access Analyzer identifies overprivileged resources in your AWS environment and validates your IAM policies against established best practices. This video shows how Datadog KIM automatically leverages AWS IAM Access Analyzer behind the scenes to give you highly accurate permissions gap detections and suggested downsized policies. If you have AWS IAM Access Analyzer enabled on the AWS end, you don't need to do anything on the Datadog end. Here's how Datadog KIM leverages that intelligence automatically. I go to Cloud Security Management Overview and see I have a few outstanding identity risks. This is KIM from Datadog. I can see AWS IAM Access Analyzer is automatically enriching Datadog KIM detections. Let's dig into some of the permissions gap detections. I'll click on AWS IAM user has a large permissions gap. I can see this is being enriched by the AWS IAM Access Analyzer. I'll pick one user from the list. I can learn more about how this user got its permissions, its configuration, and when the issue was detected. I can immediately resolve this issue by clicking on Remediate here. Here, I can see all the user's permissions and whether they were used in the last 90 days. This intel comes from AWS IAM Access Analyzer behind the scenes. Datadog KIM then also gives me a suggested downsized policy that leverages AWS IAM Access Analyzer's findings. If you don't have AWS IAM Access Analyzer enabled, Datadog KIM continually monitors permissions use for every user and role and detects permissions gap based on CloudTrail logs. Here's the suggested downsize policy, which follows the best practices. I can click on Edit Policy in AWS and update my policy to the suggested policy and achieve the zero trust principle of least privileged access. This is how Datadog KIM and AWS IAM Access Analyzer automatically work together behind the scenes.
Hopefully it was good at illustrating and kind of bringing to life what I was talking about. So from here, we're going to talk a little bit more about implementation. And we'll reference this kind of tooling as we talk about implementation, but we'll also just talk in general about philosophy for implementing best practices and also some other sorts of tooling that's out there. Now, the first guidance that we're going to give here as far as IAM best practice and auditing implementation is to really try to avoid the temptation when you need to write a new IAM policy to jump right into the tech, right? To jump right into writing your JSON. Instead, we need to be a little bit more use case driven in the way that we're developing these IAM resources. So just like we do in other types of development, focus on describing a use case, right? Describing in detail in common language what the end goal of granting access is going to be, and then also spend some time modeling scenarios. Just like we do other types of threat modeling, there's an opportunity out there to do a better job modeling scenarios around credential abuse. Now, we reason about worst case scenarios as we do this, and if the credential was leaked, what might happen, and then when we've gone through that exercise, we can think about controls, be that boundaries, service control policies, or condition keys. And then after we have thought about our use case and put it into practice, audit and test for failure, not just success. This is another thing that we're seeing in the field is that when it comes to IAM, testing for failure cases or failing to do so, failing to test for failure cases is one of the biggest mistakes that teams are making in this area, right? Because we're testing something, everything has the access that it needs, everything is working as expected, so we're happy. But in fact, we also should be testing that things are failing because of authorization errors when we would expect them not to have access to a resource. And we're going to do a quick example of this, a quick use case. So we're going to make use of our construction worker friend here. And let's say this construction worker is tasked with building a bridge, and maybe they're working with a team of other construction workers building a bridge as well, and maybe this is all part of a project called Project Archetype. And they're going to use tools, right? Just like they would use actions in the cloud, they're going to use construction tools. So they're going to be able to operate the road paver in order to do the work that they need to do. But under no circumstances, for safety reasons, do we want them to be able to use the excavator. So you can probably see where this is going. The construction workers are principal. There's going to be these two actions. So they're going to be allowed to operate the road paver. They're going to have a deny policy so that they can never operate the excavator. And if we're doing really good, right, we'll even have a condition put in place here. So we're going to make sure, we're going to use tagging. We're going to make sure that they can only use the road paver when they're working on part of Project Archetype. Now, even though we did have one condition in place, and it was good, so I'm not ragging on it, another condition that's often missed in situations like this is must be this bridge. And in this metaphor, in this use case I'm describing, this is akin to what if we made a rule that made it so that the construction worker could never use this tool outside of our team, outside of our environment, outside of our AWS account. And this is a pseudo policy that doesn't use the condition keys, right? So you can see they're allowed to start the equipment, they can stop the equipment, they can add fuel, they're allowed to use the paver. Now, with the condition keys, we have string-like, so that's making use of our tagging, right? So we're going to make sure that they can only use this resource when it's tagged with this archetype project, because that's the project that they're on. And we're also going to add this really nice condition up here in the corner, and that's string not equals AWS resource account. AWS resource account is a global condition key, and what this type of policy is going to do is we could use it with a deny, for example, and that's saying this policy can never be used to use this resource to do things outside of our account. So this is an example of an AWS, a global condition key, like I said, and there's many of them out there. Some of you might be pros at using these already, but global condition keys can do things like they could help us limit policies, restrict them to a specific account, a specific billing organization, maybe a specific IP address, a specific time frame. There's a lot of good examples. They're really powerful, and they're not used as often as you would think. So that was guidance number one. Implement starting from a use case, really make use of conditions, do better threat modeling. Next, we're going to talk about metrics. If we're the CTO or CISO of a company, I would want to know how often we're actually using tools like condition keys, service control policies, other controls. I would also like using out-of-the-box policies, and especially how often are we using wildcard policies where we're giving high levels of privilege as we're creating new roles and users. And it sounds easy in practice to measure these types of things, but it's actually quite hard to do, nearly impossible, if you don't have visibility into all the phases of your development process for IAM policy. So what can we do in order to start to know these things? Let's say you have an idea for something new you want to score, a new IAM policy. Maybe you're building it with Terraform, with infrastructure as code, and it's going to be attached to something in your environment. And there's some practices you can put into place pre-production, right? So you could use a SaaS tool, or you could use a linter in order to know whether or not this policy follows guidelines in your company, whether it matches a baseline that you maintain. And you could also check for things like, did it use a condition key? Is it protected by a permissions boundary? You can make this in construction world, maybe this is akin to, did we leave the keys in the equipment and can anyone drive it away, right? And those are things we can find out and measure pre-production. And once the policy makes it into production, we can develop a set of testing using tooling, automated reasoning. KIM solutions are a good example, like the Datadog example you saw. One of the most challenging things for security teams and operations teams is knowing when they put a policy into production, whether that change is going to break something that's running live. We've probably seen that happen before. And also how to measure the impact of the change. If that change were to create an incident, what would the impact be? Logs and metrics can really be leveraged for this. And pre-production, here are some other examples of ways that you can collect feedback before you allow a problematic policy to make it into your production environment. So CloudFormation Policy Validator is a quite popular example. This tool, I think this was released in 2023, but this actually leverages IAM Access Analyzer, and it's going to help you, before you deploy to production, identify if the policy you're about to deploy becomes more permissive or less permissive than the version it replaced, which is extremely useful. And then we also have IAM Spy, and IAM Spy is an open source tool that uses automated reasoning, and it can basically query against a set of rules and help you identify and action on IAM policy changes and the impact they're going to make. So like an example of IAM Spy, something you could use IAM Spy for would be, here's a specific action, here's a resource ARN, and IAM Spy can tell you, if we implement this, here are all the users, all the roles, all the entities in your environment who are going to gain access to the resource. And then TF-lint is also, it's an example of a Terraform linter you can use for this type of purpose. And then in addition to linters and SaaS tools like that, also adding visibility to your CI/CD strategy is a massive part of doing this well. And it could really be critical in the event that you have a security incident that results from your CI/CD pipeline and AWS credentials that are associated with your CI/CD pipeline. So that could be a variety of things: source code compromise, credentials leaked in your logs, supply chain issues, or even a compromise of your CI/CD provider. You want to have as much visibility into your CI/CD systems and your CI/CD metrics as you can. And the other really good advantage to having metrics in your continuous integration is that that's how you can start to measure that thing we were talking about earlier, right? Developer friction. Developer friction, when we introduce a tool, we want to know, is this new tool slowing down the release of our code? CI metrics can help you know that. And great tools are going to provide the right guidance to your engineers to help engineers understand how to solve the problem right away and move forward. If you're measuring metrics, CI environment, impact that you hope it is. And then one other note here on the topic of security. DevSecOps, so CI/CD systems and providers is something that increases attack surface. How many people in this room use GitHub Actions and AWS together? Probably a lot of us. For GitHub and AWS is to connect your GitHub Actions to an AWS account without long-lived static credentials. And on principle, this sounds really good, so that's using the OpenID Connect. And it's really good. We eliminate the long-term credentials, right, which is a win. We're embracing federated authentication. And don't get me wrong, it does work really well. It is the best practice. But it doesn't mean that we don't also need to be monitoring and concerned about the configuration and care and feeding of our OpenID connection here. So in fact, last year, one of our cloud security researchers, Christophe Tafani de Reaper, found a popular misconfiguration where customers of both platforms were using OpenID Connect, but not scoping the integration action was running in, right? So that's, again, an example of a condition. So for identity and access experts or aficionados out there, specifically what was going on was that the sub or subject was being configured, but not the audience attribute. And the net result of that was that these misconfigured roles were assumable by anybody who could create an OpenID Connect token anywhere in any GitHub action. So pretty serious stuff. I would definitely encourage you to go to Datadog Security Labs and you can read the whole write-up about this. It's very interesting. But the point is, anytime that we add systems, including security systems, we have to think about how we're going to monitor those systems. We have to think about how we're going to gather logs, and we have to think about how we are going to detect anomalous behavior if it arises. And then lastly, so that was quite a bit about pre-production, gathering pre-production feedback, stopping our bad IAM policies from making it to production in the first place. We're going to talk now about the production environment. And until recently, a lot of focus in the world of cloud security has in fact been on exclusively auditing things in production, or at least focusing our auditing efforts on production. Now, as we're getting better at DevSecOps, we do prevent a lot of these potential security risks from making it to production, which is good. However, as we all know, some poorly configured policies are still going to sneak through. Maybe they already exist in the environment, or maybe when we created the policy, we just didn't really have the context to know if we were crafting it well and how much permission the entity was really going to need. So it's important to audit in production as well. And here are some auditing trends that we see in production at Datadog. The best tools that we have to capture data like this are continuous scanning tools, or what you hear referred to as cloud security posture management, and cloud provider audit logs, such as CloudTrail. So like any strategy, it's not perfect if you only do continuous scanning or only ingest and distill your security metrics from CloudTrail. For example, measuring the usage of something like the number of logins that use federated authentication, which we find really does reduce your attack surface, measuring that is pretty easy. Measuring whether or not an IAM role is the right size is more challenging, which is kind of the point of all this. And measuring the control or the reason for an access decision that was made is next to impossible without having all that context that comes from understanding the configuration, the environment that the IAM resource is being used in, and trying to relate that to your audit logs. For example, here on the left, this is an example of what I was talking about with federated authentication login, right? So in and of itself, we can measure federated authentication logins. We can compare the number of federated authentication logins to the number of logins that were done using the console method. It's pretty easy to do, and we can monitor if we have adopted that best practice pattern. Now, on the right is a risk-based finding from the Datadog KIM tool that you saw earlier. KIM tools are going to create a graph of various risks-based contexts that come from logs, configuration, and automated reasoning to deduce when that particular role or policy or API usage, API access is dangerous. When we were talking about the Datadog KIM, we saw examples of what type of findings KIMs are going to surface for you. So we'll hit them again here really quick. Administrative privileges, that's pretty self-explanatory. A good KIM is going to surface for you if you have IAM entities out there that have administrative access policies attached to them. One thing that is a little bit less obvious or a little bit less straightforward is the fourth item on that list, which is privilege escalation. So perhaps a user or a role does not have administrative access itself, but perhaps it has a privilege escalation path to a role it could assume to achieve a higher level of access. A KIM is going to detect that for you, and I think it's probably a little small to see, but the third rule here on this screenshot is an example of a KIM detecting a trust policy that could be exploited for privilege escalation. You're also going to see permissions gaps, which is what you saw in the video example of underused permissions that are attached to an entity, and then guidance on how to fix that. You're going to see findings that surface IAM resources that have a large blast radius. What we mean by large blast radius is even if an IAM resource that could be exploited doesn't have administrative access, maybe some sort of context in the environment makes it a large blast radius resource, a resource that if it were to be exploited has far-reaching consequences, has a lot of room to move around, a lot of room for lateral movement. A KIM tool can detect that for you. And then a KIM tool can also find for you roles, entities that are misconfigured to allow cross-account access. And as you're looking at this, you might be thinking, detection is really good, right? But detection in isolation itself is not going to fix the problem. And you might remember at the beginning of the presentation when we talked about alert fatigue. So what we're going to do here is not just surface the finding for you, but we are also going to present a variety of actions to a variety of options to action on the finding right away from within the Datadog interface. So you can see here we've had some of these functionalities for a while in Datadog. You could create a JIRA issue. You could run a Datadog workflow. So that's an example, and this isn't exclusive to Datadog tooling. You could run a workflow, which is going to be able to maybe revoke a session, revoke credentials, or somehow make API calls to fix the misconfigured resource. And then we also have this Fix in AWS button, which is going to be a deep link to the problematic resource. So you could follow that link right there to implement the better suggested policy. These are all really good tools and very useful, but the truth is they're also kind of reactive, right? They're not proactive. And if you have worked with Datadog, I know a few of you said that you're Datadog customers, you've probably experienced on our product team the curiosity and the genuine interest in how customers are using these tools, what they want to see to make better use of it. One thing our customers have really consistently been wanting is to help them not just remediate something one-off, right? The fix in AWS button is great, but it's also an example of ClickOps. We're going to pivot over to the console. We're going to fix the role or policy there. But then what happens next time our Terraform module gets deployed? One thing our customers really wanted to see was infrastructure as code remediation. And that is what we're going to talk about next, is how to use infrastructure as code remediation to fix the problem at the source, which is usually the code repository, the code base, right? And in Datadog, for example, what the KIM tool can do is it can detect the risk. It can help you measure the impact of the risk and then prioritize the findings. So you notice, right, the color coding in the UI that's telling you, hey, focus on these red ones first. These are going to be high priority findings that are causing a problem for you. And then also with the infrastructure as code remediation, you can open a pull request to fix the issue right there. The engineer can review your pull request, merge it into your code base, and you're not going to see the same problem again. So I do have there is a video in this slide deck that demonstrates infrastructure as code remediation in the context of our cloud security management misconfigurations tool. But the example that's used in that video is an S3 bucket, and I would really like to show you an example of what I'm talking about in the context of the Datadog KIM. So I'm going to quickly, I'm going to switch over to my demo machine here, and with any luck, we'll be able to see identity risk infrastructure as code remediation in action. Okay, so this is our Datadog demo environment, and you're going to see we have all sorts of things that are messed up and jacked up in here to show you how our security tools work. So here in our Cloud Security Management Suite, we have this tool that's called Identity Risks, and this is what we've obviously been talking about throughout the presentation. You can see here in the Explorer, this is an example of many different findings that Identity Risk has generated based on the configuration of IAM resources. And what I think, and actually while we're in here, let's take a live look at what we were talking about. So this is an example of Identity Risk finding that has been enriched by AWS IAM Access Analyzer that leveraged some of that data. And you can see here under context, this is where we can see this is the IAM entity itself. This is the IAM user that's problematic. And here is the policy in particular that's attached to this user that is causing the problems. And in this demo environment, this user does have several different IAM policies attached to them. And Identity Risk is saying this specifically is the IAM policy that has been misconfigured and over-provisioned. We can see remediation steps that list the policies, the permissions that have been provisioned, and then this is that view suggested policy functionality you saw that creates the downsized policy. And then here's an example of an AWS IAM user has administrative privileges and is inactive finding. And again, this is kind of coming back to some of that more complex context that you want to be able to take advantage of in a KIM tool. So not only do we know the user has the administrative privileges, we also know this user is inactive. And that's I heard a great statistic earlier today. I wish I could remember off the top of my head, but we know this is a really big problem with IAM, right? Is that we have a lot of provisioned IAM resources in long-standing AWS environments that perhaps are being mismanaged and perhaps aren't being cleaned up. And then this becomes something in our environment that's presenting a lot of risk with no win at all. So Identity Risk here in Datadog has found this problematic user for us. And under the remediation tab, because we have this Terraform repository integrated, there's an option right here for the developer to open a pull request to the Terraform repository. And here is an example of what that pull request would look like. So our Datadog bot has created this pull request. It's going to have a link to the finding. It's going to have a link to the resource that the finding is pinging about. And you can see here, if we were to look at the diff, it's going to propose the fix for you to your Terraform resource. And you could follow whatever kind of CI/CD code review practices you already like to have in place to be able to make use of this automated remediation. And with that, I'm a huge infrastructure as code nerd, so I think it's very cool. It's very useful. I use it almost daily. Finally, the last guidance here is you saw a lot in the presentation, right? There's a lot of tooling out there. So maybe whether it's implementing IAM Access Analyzer, whether it's implementing a KIM, Datadog, Identity Risks, using some of it together, the most important thing is to start with something, right? So it's a journey, and you have to, excuse me. So it's a journey, and you have to put tooling in place that is going to enforce these best practices. They're not just going to happen by default, particularly the more hands you have crafting IAM policies, creating IAM resources in your environment. And we believe that just like building anything in the cloud, the point is to start small with this and keep building. So maybe you put the Identity Risk tool in place and you have something in production that's helping you get better at this, and then you improve upon that. Once you've adjusted, you improve upon that by putting the pre-production tooling in place, the stronger linter in place, etc. But when we think about DevSecOps, it makes the most sense to start at that fundamental system that's going to impact everything, right? And that is IAM. Now, you can also learn how to configure Datadog on AWS using the docs. And if you want to get hands-on, if you want to try some of this KIM tooling, you can sign up for a Datadog 2-week free trial using that link. You can integrate your real AWS environment. You can integrate an AWS account, and you can see how these KIM findings work. You can practice using them. And then lastly, you could send any questions to this email, technologypartners@datadoghq.com. And that's it. Thank you so much for joining me today. Talk a little bit more about IAM best practices.